Okay, hi everyone. Today what we're doing is we're going to factor trinomials. But before we get there, let's go back and review what we did before our spring break. And we just factoring in general. So the word factoring really means undo multiplication. It's kind of dividing, yes and no. It's really just undoing the mess that we made. For example, if I say a factor, the number 10, you say, okay, the factors of 10 are 2 and 5, right? Because so 2 times 5 is equal to 10. So we factored it. We broke it down into easier numbers. We undid our multiplication. 5 times 2, 2 times 5 is 10. So if we undo 10, we break it down into two parts. We break it down to 2 and 5. We ask ourselves, what do we multiply to get 10? We multiply 2 and 5. Okay, that's easy with easy numbers. If I give you something harder, if I say factor, if I say 3x squared plus 6x, okay, how can I break this apart? What did I multiply together to get 3x squared and 6x now? Well, we practiced this before. We just look for what's in common. What are terms in common? I see a 3. Hey, and isn't a 6 really 3 and 2? So there's a 3 here. And we have x's in both. X and x and x. So we're going to take what's in common. And we're going to say, okay, so we have a 3. And they both at least have one common x. So that's what they have in common. And we're going to take that out. We're going to say 3x. And we're going to write what's left over in the parentheses. And we say it's going to be x plus 2. Now, let me go ahead and highlight those. X plus 2, because we left an extra x here and a 2. So those are left behind. And if we double check it, if I say 3x times x and 3x times 2, you do end up with a 3x squared plus 6x, because 3 times 2 is 6. So we have practiced this before. So factoring is undoing, it's breaking up our pieces. Okay, and there's a couple ways of doing it. One is just looking for what's in common. But remember, we always have to write back all our original pieces. Like the factors of 10 are 2 and 5, not just 2, not just 5, but both 2 and 5. Because we have to say 2 times 5 give us back to 10. When you go to our arcade and you throw $1 into the change machine, you end up with 4 quarters, right? Because 4 quarters is still equivalent to $1. So we don't lose anything. We have to write back all the pieces that we could use to multiply back to our original problem. So again, we have to write 3x and the x plus 2, because when I multiply them back, we do end up with 3x squared plus 6x. Okay, let's do one more of these problems. So actually, no, let's go ahead and let me spend more time giving you guys examples. So what we're going to do is today we're going to factor trinomials, and trinomials can be difficult. Okay, we're going to have like 3 different types. I would call them levels 1, 2, and 3 when it comes to factoring trinomials. So let's go, and we're going to work on today with level 1 here, just to get our brains wrapped around it. So when we come up with factoring easy numbers, if I say, what are the factors of, let's say, 25? What are the factors of 32? What are the factors of 14? What are the factors of 27? Okay. We all have tricks in our brains of how would we break these numbers up. When you see 25, you of course know 5 times 5 already, right? Everyone's thinking, hey, how can I break up 25? That's going to be 5 times 5. But one trick you probably were using is because there's a 5 at the end. And when you know there's a 5 at the end, you know it's a multiple of 5. So your brain is thinking, hey, what number is 5 times what is 25? 5 times 5. So when you are factoring, you already have tricks in your brain. When you're dividing, you have tricks in your brain to say what numbers would work and what numbers wouldn't work. Look at 32. What numbers would you try to divide by? Or try to break this up into? Probably 2, right? Because it's an even number. So if the back number is even, we know we can factor by at least a 2. Even, so we can divide by 2. So if I factor this one, this is going to be 16 and 2. And you can factor this more because we want to break this down as much as we can. We can say this could be instead, well, Wait, actually, no, what are some other options? We can say it could be 8 times 4, right? Okay, that's another option. And let's look at 14 here. What breaks up into 14? Because it's even, right? That's an even number. We're still thinking 2, so it's 2 times 7. 27. Here's a trick one. It's not even, so it's not going to be 2. But we have a trick. If you add up the numbers, here's our trick for 3's. Here's our trick for 3's. If you add up the numbers, 2 plus 7 is 9. If you can divide this by 3, can you divide this by 3? Yeah, you can. That means you can divide this original number by 3. And you probably know this is 9 and 3 right now. Okay, those are my only options here. So our goal is to figure out what numbers we can break up so we can factor. So this is actually going to be our hint when it comes to harder problems. And I'm going to ask you guys to factor this problem here. For instance, x squared plus 6x plus 8. Right? Now, if you look at this problem, there is no common value in all 3 terms. There is no common value in all 3 terms. So we can't factor out a monomial like we did up here. Over here we had stuff that wasn't common. So we were able to factor that out first. Made that easy. So for this problem, where is this problem from? Let me tell you. This problem is actually x plus 2 times x plus 4. So our goal in today's lesson is we're going to get from a trinomial here, right, trinomial with x squared, and we're going to get it into 2 binomials. And that is our goal for today's lesson. We're going to get a trinomial to a binomial. And we always end up with the trinomials because when I'm multiplying binomials, and we practice this a bunch of times, let's go ahead and do it. I say x times x. We end up with x squared. Do you see x squared in this problem? The front always becomes the front. Okay, how do you think I got the back? Well, the back and the back, 2 and 4, always end up with the back. And we end up with our middle terms. Let's go ahead and show you guys this. The middle terms are 2x and 4x. Let's go ahead and write those out actually. So x times x is x squared. And then x times 4 is 4x. We're done with the x. We're going to say 2 times x. 2 times x is 2x. And 2 times 4 is 8. I want to make sure you guys understand where all these 4 parts are from. We ended up with x times x. That was our x squared. Then x times 4 is our 4x. Done with the x, then we go 2 times x is 2x. And 2 times 4 is 8. I'll make sure everyone sees those parts. Now we always end up with adding our middle terms. That was one of the things that we had practiced before. The middle terms either add or subtract depending on their signs. So the signs end up to become positive 6x plus positive 2x is x squared plus 6x plus 8. So I want you guys to be able to see this trick right now. How do we end up with the front term? Well, the front term is x, right? So we're going to end up with, for sure, x and x. That's going to be our front. What numbers could go in the back? Well, what numbers multiplied become 8? And this is where I want you guys to write this on the side. Well, numbers to become 8 are 8 and 1 and 2 and 4 times 2. Are there any other possibilities? Now please, as we learn how to do this, I want you guys to write this on the right side. Write down all your possibilities on the right side. What numbers multiply to become 8? 8 times 1 and 4 times 2. Do any of these combinations combine, add up to become 6? Looking here at my possibilities for 8. 8 and 1 and 4 and 2. do any of these possibilities add up to become 8? So, sorry, adds up to become 6? Hopefully you see that 4 and 2 add up to become 6. And guess what? 4 and 2 are also the same numbers that we had used here. If you had chosen 8 and 1, if I write here, this is the bad one, right? If you wrote x squared plus 6x plus 8, and you chose 8 and 1 instead. Let's go and take a look at what happens if you chose 8 and 1. And where am I going to put these numbers? I'm going to actually put these numbers in the back. X, 8, and 1. Does 8 and 1 add up to become 6? It doesn't. Because if I went ahead and tried double checking this problem, x and x, of course, is x squared. X and 1 would give us 1x. 8 and x's would give us 8x. And 8 times 1 would give us 8. Sure, we might get the front right? That's x squared, and that's 8. But what does 1 and 8 add up to? That's 9. We would end up with x squared. And what happens is, if you guys ever play one of those maze games where the maze looks like this, and there's a lot of dead ends. So you start here and then you're trying to find your way across. Aren't there a lot of false positives? A lot of ways that you think might be the right way, but turns out they're just traps. And when you factor, there are a lot of possibilities, and most of them are actually going to be wrong. And you have to figure out which of these combinations is the right one. Now, is that 9x what we wanted to begin with? No. So if I choose the wrong pair, we end up with the wrong combination. Now, if you look here, I have x plus 8 and x plus 2, and that takes us back to our factors, our possibilities. Okay, so let's go ahead and go over the steps again. To factor these basic problems, we're going from here to here. All right, that's our goal. We're going to undo our multiplication, because isn't x times x squared? X times 2 is 2x. 2x plus 4x is 6x, which is what we want in the middle. And 4 times 2 is 8. We are factoring it with our only possibility. We're trying to find what that possibility would be given the information that's given. Okay, let's do this again. I'll give you another problem. X squared plus 7x plus 10. Okay? So here are the steps that I'm asking you guys to do. Once you guys get the rhythm of it, you can skip some steps and yet you'll actually be able to do this all in your brain. It'll be all mental math. Okay? It'll be all mental math. So first step I want you to do is to tell me what numbers make up 10. Because this is an easy level 1 problem. The reason why it's a level 1 problem is because there are no numbers in the front. This could get more difficult with numbers in the front. Okay. And this is also a plus. Okay. I'll show you guys the difference when we have to then subtract. So far I'm asking you guys to just add them. So what two numbers multiply to become 10? What are all the possibilities? Is the back going to be 10 and 1? Right? The possibilities are 10 and 1 or 5 and 2. Are you agreeing these are the only possibilities? So let's try that. Let's actually waste our time here and let's come up with our two possibility. We have 5 and 2, 10 and 1, and how do I get x squared? That's x and x. So we're for sure we're in the front. Now here's also a thing. I can't leave these without signs. These are going to be plus plus and plus plus. If it's plus plus, it stays plus plus. I want to talk about that in a little bit more. I just want to make sure you guys can catch this pattern here. So which of these possibilities is going to give me this 7x here? Well, looking up here is 10. If you look at the sign, that's a plus sign. That means we're going to add. Is 10 plus 1, 7, is 5 plus 2, 7. Which of these possibilities seem to work for you? It's going to be 5 plus 2, right? And that's how I want you guys to think of this. What are the possibilities of 10? Because I know I'm going to have to write them. Now, which of these possibilities add up to 7? Well, 5 and 2 does. So which of these are going to work? This one's here is going to work. and this one here is not. Let's double check it. If I multiply front times front is x squared. X times 1 is 1x. 10 times x is 10x. And automatically, hopefully you can see that x and 10x do not make 7 already. And 10 times 1 is 10. Do these make 7? Nope. We know this is going to be 11x. So not the right problem. On the right side though, x times x is x squared. X times 2 is 2x. 5 times x is 5x. And 5 times 2 is 10. And you can see that 2 and 5 make 7. X squared plus 7x plus 10. It really is a game here. It's a puzzle. And we're trying to figure out which of these possibilities would break up, which of these possibilities that make up 10 would give us 7 through addition. Okay, so the answer would be x squared plus 7x plus 10. If we factor this, the only possibility would be x plus 5 and x plus 2. If you want to write it backwards, x plus 2 and x plus 5, yes, that would also be 100% okay. The order does not matter. Is there a difference between 2 times 5 or 5 times 2? They would both give us 10. Okay. Let's give us another problem. X squared plus 6x plus 5. Okay, I want you guys to think of a possibility here that would add up to 6. What are the possibilities to multiply to get 5? And which of those possibilities to add up to 6? Okay. So the way I teach this, and I want you guys to write this out, just write down the possibilities on the side. What numbers multiplied become 5? Well, 5 times 1, right? And that turns out to be my only possibility. And does 5 plus 1 become 6? It works. So how do we break it up? Well, we write our two parentheses here for our binomials. Now, what multiplies to become the front? We said for sure this is easy. This is x and x. X times x. X times x is x squared. That's how we got the front. What numbers became 5? We said for sure 5 and 1 work. 5 and 1. Now, didn't you add? So in order to get positive 6, these have to be plus 5 and plus 1. So they're both positive here. Let's see if you can figure out which numbers will make this next factor. X squared plus 9x plus 18. Okay, what numbers would work that multiply to become 18 but still add up to 9? So please on the top, please write down what numbers multiply to become 18. 1 times what is 18? 1 times 18. Then 2 times what is 18? 2 times 9. Next number, 3 times what? 3 times 6. 4, 5, that's it, we're done. These are my possibilities. So you have to know your times tables relatively well to do these quickly. Now, which of these would add up to 18? No, sorry, which of these would add up to 9? Would 1 and 18 work for us? Does that add up to 9? Does 2 and 9 add up to 9? Does 3 and 6 add up to 9? Hopefully you guys are catching that. Hey, if I write them out, I can see which one works. In this case, 3 and 6 add up to 9. So what we know for sure, the numbers are for sure going to be 3 and 6. What goes in the front? X and x, because we see x squared here, right? X times x, that's how we end up with x squared. Now, plus plus is an easy trick here. Plus plus will always be plus plus for us. But I want you guys to believe that this is true. Plus plus, well, let's double check. X times x is x squared. X times 6 is 6x. 3 times x is 3x. And 3 times 6 is 18. And as you can see, remember how we added 3 and 6 here? We have 3 and 6, and 3 plus 6 is 9. So the last number and front number are the easy numbers, but to find out which combination gives us the middle number, that is the trick in this problem of how to factor. So our answer is right here. We have undone our multiplication. We undid it. Let's do a couple more problems. If I say x squared plus, let's do plus 12x, and we'll say plus 32. Okay. Can you think of two numbers that multiply to become 32 and add up to become 12? And they're probably going to be popular ones in your head already. What numbers multiply to become 32? Do you remember the multiples that multiply to become 32? 1 and 32. If you're not sure, just do it one by one. 2. Hey, 32 divided by 2 is 16. Does 3 work? 3 does not work. 3 plus 2 is 5. That is not divisible by 3. We can't divide it by 3. How about 4? 4 and 8. 5, nope. 6, no. 7, 8, we're done. Okay, do any of these possibilities here, 132, 216, or 48, add up to become 12? Hopefully you see that 4 and 8 add up to become 12. So, sorry, running out of space here. I should have wrote it a little higher. So we know for sure now that 4 and 8 work. X and X, 4 and 8. Thank you. Plus plus, if it's plus plus, that's a freebie. That's plus plus for us. So hopefully you guys are seeing the pattern here. I'm going to throw 3 problems out here. I want you guys to try to figure them out. So x squared plus, let's do 8x plus 7. That's one problem. Please tell me what the factors are for that. X squared plus 11x plus 24. Please figure out the factors for this. And x squared plus 10x plus 21. Okay, please factor out these 3 problems and see how fast could you do it. Can you think of a number that multiplies to become 7 but adds up to become 8? Can you think of a number that multiplies to become 24 but adds up to 11? Can you think of a number that multiplies to become 21 that adds up to become 10? I'm trying to make sure you guys can see the pattern here, so you're not super confused about what numbers we're using. So since this is a level 1 problem, there are 1s in the front, invisible 1s. These are easy problems for us. We're going to add them, add to get to 8. We're going to add to get to 11. We're going to add to get to 21. Okay, let's write down the possibilities. I'll give you guys 30 seconds to see if you guys can do all 3 of these. Okay, so to break this up, we know the front's going to be x and x, right? Because x squared is x and x, right? We can just autofill that. Now the problem is we don't know what that back number is. And this back number ends up back here. That's where these back numbers end up. But we want to figure out which set works. To make 7, that's 7 and 1. And does 7 and 1 add up to 8? Yes, it does. So we know for sure we're going to use 7 and 1. What numbers add up to 21? Well, there's a bunch, right? There's 24. There's 2, 12. There's 3 and 8. We have a lot of possibilities. Oh, there's 4 and 6 still, right? There's a lot of possibilities. So if you can't find the pattern, or if you can't find which one works, maybe you want to write them all out, because it might be one of those that we don't use often. But maybe you saw that 24 is 3 and 8. And 3 and 8 does become 11. So we're sure 3 and 8. For 21, 21 is always easy, right? 21 is a 7 and 3. But it could have been 21 and 1, right? It could have been that. But isn't 7 and 3 add up to 10? 7 and 3. So we see which numbers work. Now making sure to get the right sign is the next hard part. Since these are plus plus, yes, a positive positive, positive positive, and positive positive stays positive. Okay, now if you wrote these backwards, if you wrote x plus 1 and x plus 7, 100% okay. It's the same answer. If you wrote x plus 8 and x plus 3, that's 100% okay. If you wrote x plus 3 and x plus 7, 100% again okay. All right, so let's look at a change of sign here. When will this be minuses? Well, let's look at these same questions here. X squared minus 8x minus 7. Oh, sorry, plus 7. Or x squared minus 11x plus 24. And x squared minus 10x minus, oh, sorry, plus 21. If you notice, I'm using all the same numbers. I've just changed some of the signs. Now this is when negatives come in. Now here is a trick. If it's a plus, we add. If it's a plus at the end, we add. It's a plus at the end, we add. And here's the reason why it's we still add. What numbers multiplied become 7? Well, 7 times 1, right? Do they add up to 8? They still do. But what type of 7 and what type of 8 are they? They have to be a negative 7 and a negative 1. What is negative 7 times negative 1? Don't the negatives cancel out? That's why it's still positive. They both have to be negative. And since they're both negative, if you owe me 7 and you owe me 1, you now owe me 8. They add up to become more negative. So if you see a minus plus, the back is still positive, right? So they're both negative. How do I end up with negative 11? Well, that was 8 times 3. And don't they add up to 11? They do. But they would have to be negative 8 and negative 3 to become a negative 11. And doesn't negative 8 times negative 3 still multiply to become a positive 24? So here's that trick. Figure out which sign are you going to use. Is it going to be plus, a minus? Maybe they're both positive, both negative. And here's one of the patterns. A 7 times 3, right? That's what we said. That number has not changed. But they have to be both negative now to end up with a negative 10. And let's go ahead and write that down. So these become parentheses, 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 parentheses. So if you can see that they're not plus plus anymore, it's a minus plus. We still have x and x. We still have x and x. Right? That's still in the front. X squared is still x and x. We said our numbers are going to be 7 and 1. 8 and 3. 7 and 3. These are my numbers that we chose like from before. But this time, instead of using plus plus, they have to be a minus minus. Let's talk about y again. A negative 7 times a negative 1, since they're both negative, become a positive 7. Right, that's what we wanted. But they combine out to be negative 7x and negative 1x is negative 8x, which is what we wanted. We want them to stay negative this time. Let's look at the 8 and 3. Well, what if I chose 1 to be negative and 1 to be positive? Let's see what happens here. What is a negative 8 times a positive 3? Isn't that negative 24? That's not what we want. What we want here. So either it's going to be both negative or both positive. Folks, how do we get negative 11? They're both going to have to be negative. So that's where you can double check and check your mistakes. Make sure, hey, the signs still have to come out the right way. A negative 8 and negative 3 does become negative 11, doesn't it? Which is what we wanted. And over here on the right, negative 7 and negative 3. That does give me a positive 21, right? Negative 7 times negative 3 is a positive 21. And they both do combine out to become a negative 10. Okay. So these are all still considered level 1 problems because it's just what type of rock do they throw at you? Is it plus plus? Is it a minus plus? Now here is our last one. Let me give you one more time. Let's actually do this one more time. X squared minus, let's do 15x plus 50. Okay, what do you think the possibilities would be, and which of these would give us x squared minus 15x plus 50? Okay, go ahead and try this yourself. I'm gonna write down on the side, just while you guys are doing this, all the possibilities for 50. Turns out that's it. Do any of these add up? Right, that's a plus sign there, so we're adding to 15. Hopefully you see that 5 and 10 work. X, 5 and 10. Now, do you always have to write all these? I would say if you don't automatically see the pair that works, go ahead and write them out. Okay, if you don't automatically see which pair that works in your head, write them out, and it's fine. Now, since we end up with negative 15, is that going to be plus plus? If they were both plus plus, would they become a positive 15? No, right? Because this would become plus 5x plus 10x. That becomes a positive 15. What if it was plus minus? Let's go ahead and give ourselves this option. What if it was plus minus? Well, isn't 5 times negative 10 negative 50? And that's not what we have here. So the signs themselves don't make sense. The puzzle doesn't work. So it's kind of interesting. When I was teaching my little daughter to work on puzzles, she would take a piece and she would put it on the board, and of course it didn't fit, right? But she would think, oh, it doesn't fit, and she would try to bash it in there, trying to force it in there. And of course it doesn't work. And then I had a teacher, well, if it doesn't work one way, it's not the wrong piece. Maybe you have to just rotate it. Just turn it 90 degrees and try that again, and turn it 90 degrees. And sometimes she would get it on the right side, but then it wouldn't fit perfectly. And I would have to teach her to jiggle the piece a little bit, just to shake it around so it would squeeze in there. And that's kind of what we're doing. We're fine-tuning our game here, or fine-tuning our possibilities. And it turns out it's not going to be a plus minus, but let's try minus minus. And yes, a minus minus, negative 5 times negative 5 times negative 10. This is the positive 50 we wanted, right? And negative 5x and negative 10x does give us the negative 15 we want. So this is the game. All right, here's our last one. Now, when is it plus minus or minus plus? And this is the one that's a little tricky. So let's go ahead and look at this. X squared plus 2x minus 15. Now you see that this is a negative now. And this is where we know we're going to subtract our possibilities. I'm going to write them down real quick. 1 and 15 and 5 and 3. Do any of these possibilities subtract to become 2? Do any of these possibilities subtract to become 2? Hopefully you're saying 5 and 3. 15 minus 1 is 14, right? That's not 14. And that was a fail. How about 5 and 3? Yes, 5 and 3 subtract to become 2. But right now I want you to say, who has to win? Don't the positives have to win here? So who has to be positive? Who has to be positive? The 5 or the 3? So here's where we can add the signs. I need a plus 5 and a minus 3. Because 5 minus 3 is positive 2. This is where we can add the signs. So once I write the signs there, take a look here. If I write x and x, we said 5 and 3, right? And don't we need more positives to win? So we need a positive for the 5 and a minus for the 3. So whoever is greater gets this sign, whatever that sign might be. Now I'm going to spin this problem around. I'm going to give you guys like the evil Superman version of this. Write this over here. What if I wrote x squared minus 2x minus 15? It's still 5 times 3 is 15. But who wins here? Positives or negatives? The negatives win. So what you have to do is you have to give the negative sign. You have to give the negative sign to the 5 and the positive sign to the 3. So for this problem, though almost everything looks exactly the same, take a look, we still have 5 and 3. But who gets the negative? See how negatives win here? We have to have more negatives than positives. And that's where this can be a little tricky. You want to make sure you double check your signs. Is 5x minus 3x? That's our 2x that we wanted, right? Positive 2x. Yep, that's the positive 2x we wanted. Negative 5x plus 3x, right? Negative 5x and 3x. That gives us a negative 2x that we wanted. Yep. So the goal is there's a lot of different parts now that we want to mix and match to make sure we have the right combination that fits. Okay, let's go ahead and do two of these problems at the same time. Similar to this case, x squared, let's do plus 4x minus 21. Okay, and I want you guys to factor this. And then also the next problem is x squared minus 4x minus 21. Okay, so let's think of numbers that make 21. And if you please notice, it's not plus and minus, so we know we're going to subtract these numbers to end up with 4. So you're probably thinking about what numbers multiply 21, right? And hopefully you're saying 7 and 3. 7 and 3. Now, who has to win here? The positives. So who's going to get the plus sign? Who's going to get the minus sign? Since it's a minus in the back, we know it's going to be a positive times a negative. So 7 is going to be positive because 7 has to win. And 3 is smaller, so it's going to have to lose. So you get the negative. Over here, we see that we have a negative have to win when we combine them. So 7 minus 3 is 4, yeah? It is 4. But we want more negatives to win, so we're going to flip those signs. So x, 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 and x. We know it's 7 and 3. We know 7 and 3. That is not to be debated. But what's to be debated is who wins, who gets a sign. In this case, we have more positive. So the positives have to win. Negatives lose. Negatives are smaller. In this case here, the negatives win. So we give the larger negative number to the bigger number and the plus to the smaller number. Okay. All right. So we have a couple possibilities that could happen. So let's go ahead and review real quick the possibilities here. They could be both plus plus. X squared plus 9x plus 18. Okay, they could be plus plus. And if it's a plus plus, automatically we know it's going to be plus plus. Great. Oops, sorry, that's not factorable. Sorry. 14. Sorry. What if it's x squared minus 9x plus 14? Well, in order to be a plus here and minus here, right, it has to be a minus minus. Because a negative times negative is a positive. That's how we end up with this positive at the end. And if we end up with x squared minus 2, well, that's all right, minus 5. 5x minus 14. Because it's a negative at the end, it has to be plus minus. Because a positive times a negative is negative. And they're going to cancel each other out. They're going to minus each other. And you can think of 7 and 2, subtract to become 5, right? Isn't 7 and 2 subtract to become 5? But since we need more negatives, the 7 is the negative and the 2 is the positive. X minus 7, x plus 2. X, that's 7 and 2, right? It's minus 7, x minus 2. And 7 and 2, x plus 7, x plus 2. Okay, that's it.